All right, so we're going to do the exact same thing that we just finished with in lesson 9, but we're going to add some features onto our graph. And those features are whether or not we're going to use a solid or dotted line, and then if we're going to shade above or below. So it's kind of like we're taking the previous lesson and we're adding it together with the inequalities that we already know how to do. So I'm going to start with the easier, in my opinion, of the two graphs, which is going to be this line right here. I know it's a line because the exponent on x is a 1. Before we get started, I want to remind myself that when I connect the dots, we're going to use a dotted line and we're going to shade below the graph. So this one is just a plain line, so the slope is -2/1 and the y-intercept is -1. So I'm going to go to -1 and put a point on the y-axis. For my slope, I'm going to go down 2 and right 1 until I hit the end of the graph. I'm also going to go up 2 and left 1 until I hit the end of the graph. And then I have to make sure I remember to graph, or to shade, to connect the dots with the dotted line. Then we have to talk about shading. We have to shade below this line, which would be kind of on the left, the bottom left side of the graph. So I'm going to shade that in green. And now we have to talk about the parabola. Now the parabola is going to be a little bit more work. We're going to have to do our table of values. And in order to find the middle of our table, we're going to have to use that little mini formula. So I'm going to do -b/2a. A and b in this problem, a is 1, b is 0. The -4 there is actually your c value. So I would have -0/2 times 1, which is 0/2 or just 0. So that's what goes in the middle of our table. And then I'm going to be going down 2 and up 2. And then at this point, I would use your graphing calculator and I would go to y equals, and you want to type in the function x squared minus 4, and then go to the table of values, and we're just going to copy down the y values, which are 0, -3, -4, -3, and 0. And again, you want to make sure that your y values are symmetric. That's how you're gonna. That's like a pretty good indicator that you are correct if they come out to be symmetric. Okay, so before I actually graph anything, I want to talk about the line and the shading. This one has the equal to bar underneath, so this is going to be a solid line. And then the shading, since it's greater than, will be above the graph. And this is going to look a little different because it's not a line anymore now, it's a parabola. Okay, so I have, my first point is at -2, 0. And then I have -1, -3, 0, -4, 1, -3, and then 2, 0. And I can see that they're going to cross at the point 1, -3. I can see that the 2 points overlap there. And it looks like if I kept going to the left, like maybe if I did a point at -3, so if I added a point at -3 on my table, if I go to my calculator, I can see that the y value that goes with it is 5. So if I do the point -3, 5, now I can see that is where it crosses. It's not, I still want to know, I want to be accurate and see where my graphs are crossing, but my solutions are no longer going to be ordered pairs. They're going to be areas that where my shading overlaps. So I don't want to say it's not important, because it is. You do want to know exactly where they cross, but the most important part is to know where their shading overlaps. All right, so we have to shade above this parabola. Now with parabolas, it's a little bit different when we're talking about above and below. What I like to think about, and this is one of my weird little ways of thinking of things, if I had a jug of water, so this is water, and I poured it into my graph from the top, whatever part of the graph the water would touch would be the part that is above the graph. So that, in this case, it means that inside this purple parabola would be considered above. So I'm going to shade everything inside the purple parabola in blue. But remember that our solution is actually the part where they overlap. So I'm going to attempt to do this in red. So we have a dotted line here, and then a solid line here, and then everything in between those two things that's in red, that is where the two colors of my parabolas overlapped. So that would be considered the solution. So what that means is that I could take any point that's in that red section, and if I plugged it into both of my inequalities, it would be true. If I took something that was from the green section, it would only work in the green box inequality. If I took something that's shaded in just blue, it would only work in the inequality that's in the purple box. But if it's red, it means it would work for both, so that's our solution. All right, we're going to do the same exact thing. I am again going to start with the line because I just think I like to get the easy part out of the way so that I can really focus in on what I have to do for the parabola. This is going to be a solid line because it has the equal to bar under the inequality, and when we shade, we're going to be shading above that line. Now, because it does not have an X, this is a horizontal line. So what I'm going to do is go to -1 on the y-axis, and I'm going to draw a solid horizontal line going through it. Now I think this is the most obvious of all the lines to shade above. It would be all of this stuff up here. So that's all above our line. So we're done with the bottom inequality. Now we have to talk about the top inequality. And that looks like this one. So we're going to have to do a table of values. And in order to streamline this process, we want to use that formula (-b/2a) in order to figure out what goes in the middle of our table. So I'm going to just label A, B, and C. I know we don't really need C, but it's nice just to have it anyway. So those values would be 1, 6, and 4. So this would be -6/2 times 1, which is -6/2 or -3. So that's what goes in the middle of our table. At this point, I would use your graphing calculator, and I would put that information into y equals, and then look for your the vertex in your table. So I'm going to just copy down the numbers that I see on my calculator. So my y values are -1, -4, -5, -4, and -1. So again, all you need to be able to do by hand is this x value here, and then you use your graphing calculator and you just copy down the 2 points below and the 2 points above. All right, now before we actually graph it, let's talk about solid line, dotted line, all that stuff. So I see that it's just plain less than, so that means we're going to be using a dotted line. And it's less than, so it's going to be shaded below the parabola. All right, so let's plot these points. -5, -1, so automatically I see where my parabola and line are crossing. -4, -4, -3, -5, -2, -4, and -1, -1. So I see where it crosses twice actually. So I'm going to connect the dots here with a dotted line. Okay. So I have my parabola, and now I have to remember that I'm shading below. I talked about the water thing. If I poured in water from the top, wherever the water would touch the parabola would be considered above. So in this case, below the parabola means everything outside the parabola. So that would be all of this out here and underneath, and then over here on the side as well. So it's almost like there are two separate sections of shading that would be considered our solution. So the first part, and I'm going to try to do this in red again, would be this little section, which seems like a little section, but it would actually go on forever and ever if you followed it to the left and up. And then also this section here. And again, it looks like it's, you know, a bounded section, but it's actually, it would go on forever and ever to the right and up. So those two sections, if I took any points out of those, they would make both of my inequalities true. This example is going to be slightly more challenging than the previous two. And the reason is because both of our inequalities are parabolas. Instead of having one parabola and one line, we have two parabolas. So there isn't really one that's any easier than the other. So I'm just going to start with the top one. Before I get into all the tables, let's talk about dotted versus solid. This one is going to be a dotted line because it doesn't have the equal to bar underneath the inequality. And it's a less than sign, so we will be shading below. So I'm going to go right here at the bottom here, and I'm going to make my table. I need to figure out what goes in the middle of my table, so I'm going to do some scratch work up here at the very top. Hopefully you can see this. For this top one that I just wrote in purple, my A value is -3, B is -6, and C is 3. So for my little formula here, I'd have -6 over 2 times -3, which would turn into 6 over -6 or -1. So -1 goes into the middle of my table, and then my calculator is going to do the rest of the heavy lifting, so I won't have to worry too much about figuring in all my x values and y values. So I'm typing this into my calculator, and I'm going to the table, and I'm going to tell you that, well, you can count down and up to from your vertex, and the y values are -6, 3, 6, 3, and -6. So let's go to the graph and plot these points. So -3, -6 would be here. -2, 3 would be here. -1, 6, 0, 3, and 1, -6. So this is like a really narrow parabola, and it's upside down. And the reason, by the way, that it's upside down is because your A value is negative. So I'm going to connect these with a dotted line. And we have to shade below this one. So if you can imagine, if we poured water from the top, it would hit the outside of the parabola. So we want to shade below, so that would actually be the inside of the parabola. All right, next one. I have another parabola, so I have to make another table. Before I do that, though, we would have a solid line because it has the bar underneath the inequality, and because it is a greater than symbol, we are going to be shading above. So here's my table. I'm going to do my work down here at the bottom, my -b over 2a. My A, B, and C for this problem are going to be 1, 2, and 3. So my little formula here is going to be -2 over 2 times 1, which is -2 over 2, or -1. So same same x value in the middle of our table. So now I'm going to type this into my calculator, and I'm going to go to the table, and my other x values are going to be the same as the one that's in purple, but my y values are going to be slightly different. I have 6, 3, 2, 3, and 6. So I'm going to plot these points now. I'm going to go left 3, up 6, left 2, up 3, so I have a common point there. Left 1, up 2. 0, 3, so another common point, and then 1, 6. So I'm connecting these with a solid line, and I'm shading above, so that means if I poured water from the top of the graph, anything that would be that would touch the parabola would be above, so that would be all of this here. So the part that overlaps is this part here that was a dotted line, and this part here that's a solid line, and then everything that's in between. So it's like, it's kind of this weird shape. It's like, I don't know, it looks almost like an oval, but not exactly. So that would be our solution. Any point in what I highlighted in red would make both of our inequalities true.